I am Joni and Bangahon, the Lost Reporter. At this juncture, we're going to tackle about object-oriented approach. What is object-oriented approach? When we say object-oriented approach, it is to build information systems from reusable standard components or objects. It is a way of computer programming that is based on the idea of objects to represent data and methods. For example, a car manufacturer do not create new model from scratch. New modes are actually built from standard components that also go into other modes. Let's say, for example, each model of car produced by a particular manufacturer may use the same type of engine, gearbox, alternator, rear axle, radio, and so on. Some of the car's components will be industry standard products that are used by other manufacturers. Such things as wheels, tires, spark plugs, and headlights fall into category. In fact, it may be that the only component actually created from scratch for a new car model is the body. The automobile industry operates in this fashion to stay competitive. By using standard components, car manufacturers minimize production and maintenance costs. At the same time, they can remain responsive to consumers' demands for new products and preserve manufacturing flexibility by mixing and matching components according to the customer's specification. The object-oriented model is beneficial in the following ways, such as it facilitates changes in the system at low cost. It promotes the reuse of components. It simplifies the problem of integrating components to configure large systems. And it simplifies distributed systems. The programming methodologies are non-structured programming, structured programming, and object-oriented programming. Non-structured programming is the paradigm in which the code is considered as one single block. Structured programming allows developing a program using a set of modules or functions. Object-oriented programming allows constructing a program using a set of objects and their interactions. The following are elements of object-oriented programming. First is the objects. It is something that exists with problem domain and can be identified by data attribute or behavior. Second is attributes. They describe information about the object. Third is the behavior. It specifies what the object can do. Fourth is the class. A class encapsulates the data and its behavior. Fifth is methods. It determines the behavior of a class. Lastly, message. It is a function or procedure call from one to another. The advantages of object-oriented approach are the following. Easy to understand. Reusability. As it is easy to reuse, objects are appropriate, reusable components. Reusability can be achieved by using classes that have been already written. Maintainable. This approach makes code more maintainable. Objects can be maintained separately, making, locating, and fixing problems easier. Security. It provides greater security due to data abstraction. The outside world cannot access the hidden data. Flexibility. It improved user support and flexibility in the development process. And last is lesser time and cost. It reduced time and cost for development. Features of object-oriented system. Encapsulation. It is a process of information hiding. It is simply the combination of process and data into single entity. When we say encapsulation, the data inside this unit is not accessible by outside objects. and only those functions inside this unit are able to access it. Thus, the object manages its state with the help of its methods and communicates with this object. We will require the help of the public methods of this class. Abstraction. It is the process of taking or selecting necessary method attributes to specify the object. When we say abstraction, it is an extension of encapsulation. It means providing only the necessary information to the outside world while hiding the internal details of implementation. It reveals only the appropriate operations of the objects. The advantage of this is that we can change the implementation without affecting the class, as the method interface remains the same. For example, the calculator, which takes the input from us and at the press of a button gives us the desired output while sparing us the internal details of how it has arrived at that answer. Inheritance. It is a great feature that allows to create subclasses from an existing class by inheriting the attributes and/or operations of existing class. In inheritance, we create a new class called the child class, which is derived from the class called the parent class, thus forming a hierarchy of classes. The child class reuses the data fields and methods that is required from the parent class and implements its unique functionality on its own. For example, a vehicle can be a parent class from which we can derive child classes like bike and car. Using this example, they share the common properties of being able to run on fuel and carry passengers, but they differ in the number of passengers they can carry and such more properties. Last is polymorphism. Polymorphism is the ability to take more than one form. In polymorphism, abstract entities are executed in multiple ways. It gives a way to consume a class exactly like the parent class, such that there is no confusion with mixing the type of classes, and each child class continues to keep its methods the way it was. This can be done by reusing a parent interface so that the child class can implement these methods in their own version. A polymorphism can also be applied to both objects and operations. A polymorphic object is one which its true type hides within a super or parent class. So let us move to the auditor's role in the conceptual system design. The auditor is a stakeholder in all financial systems and thus has an interest in conceptual design stage of the system. The auditability of a system depends in part on its design characteristic. Some computer auditing techniques require systems to be designed with special audit features that are integral to the system. These audit features must be specified at the conceptual design stage. In addition, the auditor develop and evaluate the standards of control and security of the financial system, since they work closely with the designers of the system. Such matter allows to ensure that the standards of the control and security are appropriate and sufficient. As we all know, an auditor plays an essential role in the conceptual system design as they review and develop process to ensure the software is designed with user requirements documented, that management approves the design, and that the application is tested before implementation. That's end my report. Hope you learned something.